Objectives for 4.4. Remember, we're on the section of logarithms and exponents. The objectives for 4.4 talk about using like bases to solve exponential equations, using logarithms to solve exponential equations, using the definition of a logarithm to solve an equation, and using the one-to-one property of logarithms to solve equations. And then, of course, the last one, you remember what that means, right? Solving applied problems involving exponents and logarithmic equations. So that means word problems. Right? So all the stuff I've taught you how to do before, it's just the same sort of thing in a word problem. Okay? So first of all, what if we have a problem like this? 3 to the 4th equals 3 to the x plus 1. Well, if 3 to the 4th has to equal 3 to the x plus 1, is it fairly obvious to you that 4 needs to equal x plus 1? Can we just literally ignore the bases right there? It is, okay? So hopefully I can write this correctly and we can get an answer of 3 fairly quickly. And if I put it back, I keep saying obviously, I don't mean to say that. 3 plus 1 is 4, 3 to the 4th equals 3 to the 4th. We know that this is correct because we substituted it in and got a correct answer, okay? Now, we actually don't care what 3 to the 4th is, do we? But we know that 3 to the 4th equals 3 to the 4th, and so that's good enough to go on. Okay? The problem comes when the issue comes when it looks like this. Because I can't just say 3x minus 8 equals 1, because this exponent equals this exponent. That only works if the bases are the same. Well, these bases are not the same, so is that a huge issue? Well, it would be, except I can make this number become this base, can't I? I can say 2 to the 3x minus 8 is exactly the same as 2 to the 4th, right? Now can I ignore the bases and set the exponents equal to each other? Absolutely. 3x minus 8 equals 4. Add 8 to both sides, 3x equals 12. Dividing both sides by 3 gives me x equals 4. Well, is that really true? 3 times 4 is 12. 12 minus 8 is 4. 2 to the 4th power is, does 16 equal 16? Then I know that's the correct answer. Okay? Now, there are times when it's not even as easy as this is because of the fact that this is already a 2 and this is a 16. Sometimes it might look like this. 27 to the x plus 3 power equals 9 to the x minus 1 power. I can't make 27 become 9, and I can't make 9 become 27. But what can I do? Make them 3s. I can make them both those bases of 3s. Now I'm going to have to use some of my exponent properties, right? Because I know 27 is 3 to the 3rd, and then that's raised to the x plus 3 power. I know that 9 is 3 squared, and that's raised to the x minus 1 power. Now that the bases are the same, what do I do with these exponents? I do multiply because it's a power to a power, right? So I have 3 times x plus 3 equals 2 times x minus 1. And again, that's a simple equation that we've been solving for a long time now. 3x plus 9 equals 2x minus 2 minus 2x minus 2x minus 9 minus 9. X equals negative 11. Negative 11 plus 3. So 27 to the negative 8. Negative 11 minus 1. What did you say? I wrote down what you said. I'm sorry. So 27 to the negative 8 equals 9 to the negative 12. Is it? Well, we could check, right? Oh, go away. 27 raised to the negative 8 power. 9 raised to the negative 12 power. I don't even care what it is. What I care is that they're exactly the same, right? I don't have to go write that down anywhere. What I care is that they are exactly the same, so I know that that is my correct answer. Does that make sense? Okay. So that was our objective about using like bases to solve exponential equations. Okay? So that took care of our first objectives, those three examples. Our next objective says use logarithms to solve exponential equations. Okay? If we're using a logarithm to solve an exponential equation, we have an equation that looks like this. 4 to the x equals 15. It's problems like this that give us the need for logarithms. Okay? Let's see, how do I want to explain this? We want to take the log of both sides. That's going to help us get the variable out of the exponent, right? Because if I take the log of both sides, let me write it down so you see what I'm saying. If I take the log of both sides, what happens to this x right here? It goes smooth to the front, right? So I have x log of 4 equals log of 15. And to solve for x, all I have to do is what? Divide by log of 4. So in my document, right here, I could say, where is it? There it is. Log 15, not that, 15 over log of 4. So oh, you can't even see that, I'm sorry. 1.95345. So that's one way to do this problem. Okay? Why did I choose log base 10? Because it's easy. Could I have chosen another base? What base could I have chosen? I could have chosen e. So instead of taking the log of both sides, I could have taken the natural log of both sides. Like that. Is that what you're telling me? Do all the same rules apply to logarithms, or to natural logs that apply to logarithms? So what happens to this? So x natural log of 4 equals natural log of 15. So if I divide both sides by natural log of 4, natural log of 15 divided by natural log of 4, oh look, it's exactly the same. 1.95345. That's another possible way to do it. Okay? But, as you just said, couldn't we just put it in logarithmic form? Yeah, what would it look like in logarithmic form? Log base 4 of 15 equals x. We could either do change of base formula if we only had our phone, or if we have our calculator, we could do log base 4 of 15. You know that if I know more than one way to do a problem, I want to show you all the ways. Okay? Any of the ways we did it, we got exactly the same answer. That's the point I was trying to make. Okay? Yes, you can take the log of both sides to solve it. Yes, you can take the natural log of both sides. Yes, you can put it in logarithmic form to solve it. Any of the ways it works. Okay? But another way, just think about it for a second, and it's obviously going to end up with the same answer. Okay? But what if I took the log base 4 of both sides? Why would I purposely take the log base 4 of both sides? When the bases are the same, what's left? Yeah. So x is going to equal log base 4 of 15. Now we got there exactly the same way because if we put it in logarithmic form, that's what it ends up being. So you know very well that the answer is going to end up being 95345 because I just literally put that in my calculator. But that's another way to think about it. Okay? So there's multiple ways to solve these kind of problems. I don't care which way you do it. I want you to be comfortable. Find a way that works for you. Is that fair? Okay. So in a problem that looks like this, what do we need to do first? Add 3. 40 e to the 0.6x equals 240. What do I do next? On both sides, right? 40, 40. E to the 0.6x equals 6. Okay. How do you want to solve it from here? Some people have a hard time putting this in logarithmic form or exponential form. You know what I'm saying? They have trouble going back and forth because it says e. And they want to say log base e of 6 equals 0.6x. We know that we don't say log base e. We could, and we could put it in the calculator and it's going to do for us. I want us to know mathematically really what's happening. Okay? So how do you want to do this? Natural log? Do you want to put it in natural log form, like in logarithmic form, or do you want to take the log of both sides? Again, it doesn't matter. Okay, so if I do that, then it's natural log, so log base e of 6 equals 0.6x. That's just from the calculator. Do you need me to show you? You trust me? Okay, awesome. Questions? What do you think people try to do? Yes? This is really log base e of 6 equals 0.6x. But remember, we don't write log base e, we write natural log. That's why I wrote that. Does that make sense? Okay. Mm-hmm. Yeah. Okay. It's fine. What do you think people try to do here? What do you think bad people try to do here? They set the exponents equal to each other and solve. We can't do that because the bases are not the same. Okay? So the only thing we can do is take the log of both sides. We can't even write this in exponential form. Okay? We can't do that on this kind of problem. So we do have to solve this one by taking the log of both sides. Okay? Doesn't matter what kind of log we take of both sides. No? So do you want to take natural log or common log? Natural log, okay. Natural log, natural log. So what happens with the x minus 2? X minus 2, natural log of 5, equals, same thing with this, 2x plus 3, natural log of 4. Now what? Distribute, okay. So, like that, and like that. So I get x natural log of 5 minus 2 natural log of 5 equals 2x natural log of 4 minus 3 natural log of 4. Which x am I solving for? It's only one x, right? It's written in two different places right now, but I've got to do something to get those together. So I need to get all the terms with the x's on one side and all the terms without the x's on the other side. So add 2 natural log of 5. I can do that. If I do that, then I'm also subtracting 2x natural log of 4, right? What did I say? This? Yes, thank you. Yeah, thank you. So I have x natural log of 5 minus 2x natural log of 4 equals, because that's 0, right? And that's 0. So I have 3 natural log of 4 plus 2 natural log of 5. Okay, so far? How do I get these x's together? Because I can't just add them together. I can't just say x minus 2x is negative x because of this whole natural log thing right here. I factor it. Okay? If I factor out an x, I get natural log of 5 minus 2 natural log of 4. Does that make sense? Equals 3 natural log of 4 plus 2 natural log of 5. Now, how do I solve for that x? This, do you guys see that this is a constant right here? Natural log of 5 minus 2 natural log of 4. I mean, I know it looks like a bunch of mess, but this is a number. Like when I take the natural log of 5, I'm going to get a number, and 2 natural log of 4, I'm going to get a number. So if I subtract a number from a number, it's just a number. It's just a constant. So I just divide that. I just haven't taken the time to put it in my calculator and figure out what it is, because I don't ever like to round until the very end, right? So natural log of 5 minus 2 natural log of 4. So to actually solve for x, I need to just put that straight into my calculator. Three natural log of 4 plus 2 natural log of 5. Dang it. And then natural log of 5 minus 2 natural log of 4. Negative 6.34291. Now, how do you know what answer to put in the computer? Do I put in negative 6.34291? Do I put in negative 6.3429? Do I put in negative 6.343? What do I put? It'll tell you. Yeah, it'll tell you how many decimal places to round to. Okay? So just be aware of that. Okay? So all the problems we've done so far have started in exponential form, right? What if they start in logarithmic form? What if they start log base 4 of x plus 3 equals 2? How are we going to solve that? How many ways are there? Maybe. What's the one that you can think of? Exponential form. If it starts in logarithmic form, try putting it in exponential form. If we do that, we get 4 squared equals, okay, surely we can do that problem, right? 16 equals x plus 3, subtract 3, x equals 13. 13 plus 3 is 16, right? Log base 4 of 16. I could try to do that in my head by saying 4 to what power equals 16? 2. Does 2 equal 2? But if I don't feel confident, can I put that straight in the calculator and see what it says? Remember this, please. Log base 4 of 16. No. 4 of 16. Where is it? Not there. Stop. Clearly. Dang it. Where is it? Oh, it's right there. Escape equals 2. I should put it straight in. Log base 4 of 16 equals 2. And hit enter. And it says true. That means it's right. Okay? 3 natural log of 2x equals 12. To solve this, divide both sides by 3. What do you think people try to do with this too? They try to divide it. Can you divide it? No. It's inside. How do I solve it from here? Exponential form says e to the 4th equals 2x. Do you know e to the 4th off the top of your head? Me neither. E to the 4th. That's 54.5982. And then to get the answer, I just divide both sides by 2. And that's how I get 27.2991. Okay? What happens if they give you an equation and there's more than one log in the equation? Can you condense the problem and then solve it? Do I need to show you examples about that, or you feel confident with that? Because you seemed pretty confident with condensing when we first did it, right? So if there's more than one log in the problem, just condense it and solve the way that we just talked about.